Okay, hello everyone. This is Thanh Nguyen with ASPEN, and I'm glad to be here today to show you a few things about what's new in ASPEN OneLiner. And I thank you for, first of all, thank you for your time that you are willing to spend to be with me here, and I hope I am able to show you something interesting. And so if you have any questions or you have any problem with audio or something, this is how you can enter these questions or concerns. So if you don't hear me, for example, then go ahead, or the audio is bad, go ahead, enter something here now in the chat, or you can also send email to support@aspeninc.com. Okay, and so we'll try to do it in about 40-45 minutes, and I will collect all your questions during that time, and we will try to go through them at the end of the presentation. Yes, I will be recording this presentation, and I will send you a link to view it later on if you need to, so you don't have to record it yourself. Okay, and I will send you a link to the recording after this. And all right, so let's see what's new in ASPEN OneLiner version 14. Version 14 is, we've been working on it for about more than 2 years, and right now, as of today, we name it version 14.3, and it is available on CD, which is being mailed out to users in batches. So, some of you already received something, some should expect to receive something soon. And you can always just call up or send email to ASPEN to request a download link directly. And just a note here that you can don't have to uninstall the version 12 in order to run version 14. You can run it side by side and remove the version 12 when you are comfortable with the new version. And with this as an asterisk here, that's saying that you need to be aware that if you save the file in the version 14 and go and open it in version 12, something not right may happen. So if you have new feature that you enter into version 14, those features may be lost in version 12. So be aware of that. Otherwise, the fault simulation and most of the other commands should work the same. Okay, so what's new? I kind of try to categorize them in those 4 different areas. What's new in different network model and relay models, and what's new in simulation and report, and lastly, what's new in the way you interact and work with the programs. Okay, that's the sequence I try to present here. Okay, so first, we have a brand new model for the device called voltage control current source, and this is a generic short circuit model that you can use for equipments with DC-AC or back-to-back converter interface to the network. So some example are voltage source converter, type 4 wind turbines, photovoltaic, or fuel cells. And that is the complement to the current limited generator model in OneLiner that you have been that we've been using. And so beside that, we have also add a number of new model attributes that let you extend the capability of existing model. Some of them here are the normal state of switches, normal close, normal open, and normally don't care the n/a. So let me open the program here a little bit and show it to you. If I open say let's see if I can find a switch which is here. Okay, so in a switch here, you see there's 3 new buttons here that say normally closed, normally open, or not care, not available. So if you say this thing is normally open, okay, then the state of the switch here can be controlled by a command under network, set all switches to normal state. So with this single command, you throw everything to the standard configuration for your network. So this one command doesn't let you, a feature that lets you define a normal condition in your network, and with a single command restore everything to it. Additionally, you can also specify separate resistance parameter for switch. Some of you may be surprised to find that switch has resistance here, and it does. And if you go to the program option for network, and you used to be able to enter only the reactance or switch, but now you should be able to also specify something for resistance. And why it's important, because if you run the breaker rating studies, and sometimes without this small resistance or reactance, the program can result in, the result can be for the NC XOVA ratio, it can be quite confusing sometimes. So that's another goodie that you have. And you can also now enter switches in parallel if you want to, in order to represent the correct breaker condition configuration. And you can also, another new model parameter is the new MBA rating for phase shifter, which you can use for different PRC checking purposes. Okay. And another couple of very important modeling extension is for all the equipment in the network. Now you can enter the availability date, and they looks like this. So if you look open the line, you have 2 new fields called in service date and out of service date. So for example, this one is set to be in service in it's out of service in 2014, but back in service in 2021, basically. So you can have all those combination of in service and out of service date or equipments. And what does it do? It has, so once you have those commands and those dates, you can say file, save me a copy of new study date, and this command basically will make a copy of your network, and then for the date that you want. For example, I want the date of 2016 for 18, for example. I want to perform a study. I don't need to enter the day or month if I don't want to. So if I say that I have a copy of this file with thing that is out of service or in service according to what they are supposed to be. Okay, so that's the the idea. Okay, and with that command, you can create a different version of your network quickly that match your study date if you took care to enter all those dates in your network. Okay, and next we have added a few new protective equipment model to the program. One of them is new voltage relays, which device that sends the voltage level and trip accordingly. So the voltage relay model here, you can enter, it's a generic, it doesn't fully matches any of the specific manufacturer. Those will be coming later, but this is a more or less a generic model that you can enter, which has the over voltage component and the under voltage component. Okay, so you can set it to operate on different kind of voltages. What is showing here is phase to neutral. You can also set it to operate on phase to phase, or 3V0, or the negative sequence, and so on. And for each of the voltage and element, you can also set a time delay, or and also an instantaneous element. So there are all kind of combinations that you can make, and you can use to simulate the voltage protection in your model. And in addition to this, we can also actually, this is a typo. It should say new line differential relay model. I'm sorry. Okay. And this is another new relay model that you can enter in version 14. It has the again, this is a generic model that you can use to match many of the existing relays and future relays, as long as they operate in the same principle. And what it allows you to do is to enter for each relay a local current input, and also up to 2 remote devices. Okay, so the program will report a current relay trip when your fault simulation produce a differential current among all those inputs that exceed all these different threshold for phase, for 3I0, and for negative sequence. Okay, so for example, if you want to do a line differential that get 2 411 relay at 2 ends, you will add this one at one end and add another one at the remote end, and make the each other, they use each other input. So and then when you have the fault simulation run inside the line, and the differential current will obviously exceed the threshold here, and you see the reported tripping. Okay, and you can also even model some of the tap and load coordination feature that are part of many new differential relays. For example, the 411 or 311s, and SCL, and also for some G devices, which you set the delay of the differential element to allow it to coordinate with the protection at the tap station inside the protection zone. So, okay, and so another new model for relay elements is that if you have an SCL relay, overcurrent relays, you now can specifically model the directional logic correctly. And so let me maybe just show you this on an example. So let me open the other file. So if I have an overcurrent ground relay here, and those and those are the first two are the directional setting that you used to have, and those the next two are the one that specifically created that matches the SCL logic. So once you select that, you can enter the settings that that matches the SCL devices, and the program will use those settings to calculate the directional reaction of the relay during any form simulation. Okay, and it also, this is for the ground relay, but if you can also have phase overcurrent relay, you can also have that. So if I add a new distant phase relay, and no, not distance, I'm sorry, an overcurrent ground phase relay, then in addition to just voltage polarized, you can also have the negative sequence directional settings and simulation here, built in here directly. Okay. Which is I am showing here in this device. Okay, and lastly, we also added a couple of new manufacturer-specific model for a couple of Chinese made relay. One of those, if you are in South America or Southeast Asia, you will be familiar with those devices, and you can, if you have them on your network, you can simulate them directly here. Okay, so there are a number of new relay model attributes that I want to point out to you, and one of them is the multiplier and adder. Okay, so if you go back here, and in the we used to have only one set of time adder and multiplier parameter for the entire relay, which apply both to time elements and the instantaneous elements, which limit the application of those parameters, because in many modern microprocessor relays, the time adder and multiplier can apply separately or differently to those elements. So in this version, you can now just have a separate parameter for each of those elements, and that makes it easier for you to simulate those components correctly in your network. Okay, and also in this version, you can enter for every protective relay element a long string with so-called asset ID, and they are a field here. Okay, that's in addition to a shorter ID here. So the ID here is will be used for identification of this device inside the ASPEN program, and this field here is meant for you to use in data exchange with external database that you may have, an access-based database that you may have, and that makes it much easier to match those data records. Okay. All right, going further. Now we come to the part where I'd like to show you a few what's new in terms of simulation study and the report that that you can create in the ASPEN program in version 14. And the first thing I want to show you is the so-called brand new command that is called line for summary. And you start this command with just select a line here, and I guess go to the for. Just select a relay group in front of the line and say go to so say line for summary. What does this command do? It's designed to run a range of fault simulation, which you can select the type with or without all different kind of outage, and with one or a range of fault impedances. Okay, and that simulation is done at the local station, or at the remote end of the line, and also at the remote end of the remote line. And if you want, you can go even one level further to the far end of at the remote end of the line. Okay, so at each of those locations, all of those faults here will be simulated with all of those outages. You can also additionally simulate a have the program simulate a so-called breaker failure condition at the remote end when you have the line fall on this remote line. So for example, if the line of the phone is here and the relay here failed to somehow open, and this relay here will have to clear that as a backup, but then for some reason you have this breaker failure, then you have a certain condition that this line is connected, but then everything else is disconnected. So this is called radio connection, and also if that's a radio option you can specify, and also you can specify the breaker failure. The result is so-called stop fall, and you can look it up in the help file to see what exactly this means. But it just means that the two lines are connected. There's a couple of stuck breakers, so the two lines are connected with the fall over here, and everything else is still connected on the other side. Okay, and so when this simulation will result in some kind of a report like this here. And the report basically is a summary of at each of those locations, say close in, which is the at the local station, the far bus, which is at the far end of the line, the end of line 1, which is the far end of the line with the remote end already open, and that's a repeat for the remote line and also remote line, and also for the radio stuck breaker condition. So for each of those conditions, if you look across, you'll see the report of minimum and maximum phase current, minimum and maximum ground current, and minimum and maximum of the sequence current. Okay, and in addition to the minimum and maximum of the apparent impedance that's seen from the relay location in across all of those outages and condition at each of those locations. For example, if we look at this, we will can tell that for the end of line condition, the relay here will see the minimum of 1389 amps in phase current, and the maximum of 1675 amps in the phase current. And for the ground current, you can see about 1399 amps, and so on. And so on. And if the relay, the phase relay here will see for the end of line a minimum of 32 and maximum of 32 ohms, and the ground relay will see about 32 ohms as well. Okay, so that's a table summary across all of those conditions, and it's also show you a list of remote buses that remote end is taken into account here. So if you have a line with tap buses or switches and at the in the middle, the command is designed to go across that to go to the correct end. Okay, so that's the summary table. And also if you select the where's that if you select the no, I'm sorry, I need to find. If you select this the report to CSV file, then you'll have the CSV, which is a file that Excel can open. You'll have the detailed Excel table for every form that it has simulated, all the information about that form, the currents and the voltages and the impedance, so that you can make use of that Excel table if you want to produce additional report that you need to. Okay, so that's the line fault summary command. So if you need to say basically set a line relay, most likely this one command will provide you with most of the form information that you will need, either directly in that summary table or in one of those CSV files. Okay. Okay, so that's the line fault summary. Another important feature that we have added brand new in this program is a new tool for doing the relay line protection, for relay coordination. the so-called time distance diagram. The time distance diagram is designed as a separate window similar to the overcurrent or distance relay, and it shows the local and remote lines. There can be as many lines as you want, and it shows the plot of relay operating time on those lines in both forward and reverse directions. And so you can coordinate, you see if your local relay is correctly backing up the fault on the remote line or vice versa, or when you may have the problem. So, okay, so I do a quick demo on this one so that you know what I'm talking about, okay? I have right here, okay, and this is a line that say from here, and I have another line going off this all the way here. So I want to see if those relay here are correctly set up to back up this line, and also this line is correctly backing up this line. Okay, so I right click here and say view time distance diagram, and if this is a separate window that you can move around. Okay, I have only one monitor, so I need to move it back and forth like that. So you'll see it is the impedance model of the line. So this line from bus 525 to 421, this is the internal impedance. If you move this the cursor, you will see this is how far in terms of ohms each point is in this axis, and this axis is supposed to show the time relay time in seconds. Okay, so I have, let me add the next line. So this 421 421 is here. Okay, and 537 is here, but apparently there's no relays here, obviously. So I guess there's no protection here. But then from 421, I can go further to the next line here, and so I should add to it. So let me go back. So I go here and say right click here and say add branch to the right. So I click this branch going further. Okay, so now I'm showing the impedance of first line and another line going here. Okay, so I start my relay is here. So I say just add, there's a ground relay here. I add it to this position to monitor it, and I want to see if that is correctly coordinating with the ground protection here. Okay, so well, and then now I want to see if the fault is happening here on those lines, how those relays will be reacting. So I say specify option ground fault, and then just plot the time distance curve. Okay, what is showing here actually is more interesting to look at this portion. That means if the fault is happened somewhere here, let me add a slider here. It shows that if the fault happened on this point of the line in terms of impedance, not in terms of mile, in terms of impedance, then the relay here is tripping instantaneously, and the relay here tripping at 1.2 seconds, and so on. You can see how those relay are coordinated with each other, right? So those are the two. You can also do the mix of overcurrent and distance as well. Let's see if I have that. So if I on this looking back from this end, I add and say overcurrent phase relay, and then I add another relay here. I don't have any distance relay. Sorry. Oh no, I don't. Well, I guess if there were distant relay here, I would be able to show that as well. I may have that in some other location, but not here. Okay, so I run the so change the option to 3-phase, and then I run it. Okay, so the phase relay here now I can see that it's coordinating correctly with the phase relay on this line. Okay. So that's the tool that you can have, and Yeah, I think I should have some phase, some distance element here in order to show it correctly, but I guess I don't. Okay, let's see, that's time distance. And uh, well, I don't have the in the demo, but I think I do have this picture here that I can show you. So there's in this picture, what I'm showing, what we have at the play tool position is a phase relay that has zone 1 covering about this much. I know this zone 1 because if I look across, I see this tripping zone 0 seconds for fall that spanning this line up to here. And from here to here, I can see that it's tripping zone 2 because the time now is about 0.5. Okay, and further is a fall start happening here, and this relay will trip zone 3. Okay, and when the falls on this line, there's another relay at Nevada here that trips zone 1 from here to here. Trip zone 1, I mean let's see what I was saying. Okay, yeah, the zone 1 here, that means it's almost instantaneously, and you go here, your zone 2, that means if the fall is somewhere on this line, between here and here, we have zone 2 trip of the local relay and zone 3 trip of the remote relay. So we seem to be doing fine here in terms of coordination. Okay. And that's the time distance diagram feature. Okay. Let's see. Okay, so we have added to the program collections of command features that make it easier for you to run study that meet the PRC and different PRC standard compliance. And I have listed a few here. Those are number. And for those of you who are familiar with those standards, the 23 is the standard that specified the threshold where you should not be tripping on load. Okay, so with a certain load level, you have to check if your relay is tripping or not on those conditions. And this check has been available in OneLiner for some time, but in this version 14, you can actually take a new latest requirement in PRC 23 is to take the load as the rating of transformer and phase shifter. And now you can use those numbers as threshold to check your relay as well. So PRC 23 is extended to cover the rating of transformer and phase shifter. PRC 25 is the one that specified the your generator has to be maintained to be running to ride through the certain fall condition, and there's a very sophisticated calculation. Okay, actually I do have some picture here. So I show. So this is a 23 that let you show all this region where the load region that the falls not the relay not supposed to trip, and you can use this load here from and transform rating now. So that's a new thing. Okay, in the overcurrent relay windows, you can specify you can draw a line like that to show that rating. Okay, and 25. This is a tool that check if the generator construction relays as whether they're tripping when they're not supposed to, and this involve a set of network and condition and calculation that PRC go into a very detail, but in a short description, basically you specified a region on your RX diagram based on which depend on the network on the generator side, also network on the other side, and this is the boundary. And if you perform that calculation according to PRC 25, then you can plot something like a straight line here. And so the program in the distance relay windows now, you can go to the add menu here, and you can add PRC 25 threshold, and it will take the network condition into account, perform the calculation, and plot this picture for you to retain as the proof of compliance. So not only you have the graphic, you can also the program also print the result of those calculations as all the details are required in the PRC standard, and that you can print out. So basically, the goal here is to let you quickly produce a compliance document based on those calculations, as well as performing the calculation. Okay. So that's PRC 25. For the same token, the same kind of approach, we use we have the tool that you can calculate the threshold or the limit that the relay should be performed correctly during the power swing, and the calculation here is also automatically done based on the network model that you already have at the relay location, and as a result, you will have a plot, something like that, with the so I call it the butterfly shape, which is the combination of the big circle here for the swing, and also the arc here for the magnitude of the different ratio of the magnitude of the sources. Okay, so I guess that's those calculation details also provided for your as a report in the TTY window. At the same time, you're plotting it. So again, this command is under add, and it will say add relay. Okay, let me just open the program and show it to you. Okay, so let's see if I have relay here, and so if you add here, it's called unstable power swing region, and the generator loadability limit is the PRC 25. Okay, so if you're watching this and you are not from the US, those are the how you translate the 25 into English and the 26 into English. Okay. Anyway, so let's go further. We have also added some neat tool for you to show that you are in compliance with 27, which is the standard that that seeks to maintain the coordination of protective relays over time. So over time, the network condition can change. So you will have to either every 6 years or some others, or when the network has changed by certain threshold, perform the coordination study to show that your existing setting is still correctly working correctly for the new network, and so on. So the tool that we provide is the extension of a bus fault summary command that you have been using in the program for several versions to produce some summary of fault current at every buses. Okay, so now this is a typical report that you will get from if you run that in the version 14, and instead of just specifying what bus you want to fall, you will take as the program will take as an input an existing bus fault summary report. Okay, and it will produce a report something like that with the list of buses where the current deviate from the baseline number by a certain percentage. Okay. Okay. So let me try to show that to you in a quick demo. Let me open This is a network called one network, and I have run. Let's see. I have where's that? Okay, so I have run the bus fault summary for this network, and I have received a report like that at certain point in the past. Okay, so this report is for each bus in the network. It shows what's the phase current and what's the ground current on each bus, and also it has a summary of maximum phase current and ground current for every buses. Okay, so this is the report that I used to have. Okay, now if okay, actually I had to open a different file, which is the network that I had already changed after some time, and I want to find out if the fault level has changed, and if so, how many locations that exceed that threshold. I just go and say bus fault summary. And now instead of specified where the fault should be applied, I will just go here and say apply the fault to the buses in a baseline summary report, which is the one that I showed you earlier. And then at the same time, flag all the buses where percent current deviation exceed a certain threshold. Okay. Then that's the idea. So if I click OK here, I'm going to be asked to enter baseline bus fault summary report. Okay, and the baseline I show you it is this file summary one here. Okay, so now I'm asked to enter the name for the new report, which is let's just take this name here. Okay, yes, I want to replace it. Okay, so now the program is had take the input as the first summary, and then it know what buses are in that file, and it produce the same run the same fault simulation and produce a new set of fault current, and it will produce a report something like this with the new data file name, the baseline input, and the output file name. Okay, so all of those simulation options here are exactly like the one that was found in the previous report. And now comes the summary table, where there's a number of buses where the current has changed by more than 15%, okay, based on what's the baseline. And also, it also you can see here some additional report where in this new file, it say it couldn't find some buses that it was there before, but it's not. So over time can change, okay? And you can also see, for example, on this line here with the baseline is 0 now. So that means those are new buses in this file. So the program takes all those into account, and so those will be the buses where you may want to not this one, but those 1, 2, 3 are the one that have the percent change from the baseline, quite different from right now. So you may want to go there and do the fall, do the relay coordination study, for example. And now the program also record all the new simulation here, and also if you look at the end of this table here, there's those baseline current from the previous report are carried over here. So that means we just carry the baseline from one study to another until, so you can repeat that for every year, every 2 years, so that until you find the time if you find that the change from the baseline exceeds the threshold, then that is when you will need to perform the PRC 27 study. Okay, so that is the idea. Okay. Okay. Okay, so that's the new study, new report, and okay, so there's another report and application that we have in this program, in this version is we create a so-called tag browser, and that is found under the network. Oh, there's no tag here. So if I say add a tag on this line, for example, say I'll explain that later, and then I can also add another tag here. Okay. Now, if I can go and say tag browser. So the all these tag will be grouped here alphabetically, and then when you highlight an tag, a list of components that has that tag will be listed here, and you can easily say take. So if it's off, I say take out of service of that. So that will be, so the line or everything else you tag with the same tag will be out of service. So that's, we see that as a tool that you can apply for different purposes, and one of those could be the project management. You tag everything with the project name and also the on and the off keyword, and then in the tag browser they will be listed together, and you can take everything offline and put everything online. So you can like put the project in service that way. You can also use a tag browser if you know to specify the in-service date and out-of-service date. And that way you can link the project in-service and out-service date to the tag and take them out in and out of service. Okay. Now, the program also now record the certain journal entry for every time you edit something. So if I just edit something here, so if I say add here, it not only lists the last change date, but it also lists who made it. And if you create a new component now, it's also record the date and the creator here. So if you look here and you find this number of questionable, and you click here, you know that Tang is the last guy who changed that, and he's then you know who to call to ask questions about number here. So that's the idea. Okay, so that's the some of the new report and capability. Now we we are also enhance the way you interact and use the program to get more productivities. And one of those areas is the phasor diagram, and for that with the emphasize on for location. Okay, I do that in an example here. Let me go and open the for location thing here. Okay, so if I have an event just happen on this line somewhere, and I have the recording of it, okay? And the task here is that I want to find out where that happened so that I can send an inspection crew out. And one way you can do that, if you have a good model of the line on that's already goodly calibrated, then you can run the for simulation along the line or at the adjacent line and try to match that recording to the location of the simulation, and then report it as most likely a location. Now we allow you to, in this program you can speed that whole process up by automatically do all of those things. So if I run the demo here, I say right click here and say for locator, okay, and then the program has a button here for me to enter all the recorded value directly from the event file. I click read from file if I want, and select the event file. And this could be the SCL event file, or it could be GE or anything that recorded in the complete. So it takes the SCL event file in the complete format for now. Okay. Okay. So if I so this event file has two events recorded. I select this one, and I can show that this. I can see that this is the beginning of the fall. Right. So I guess you see, I use the mouse to move the cursor to the section where I have more or less a stable fall condition, and I have all these phaser here, recorded here, and then I can click OK, then all those phaser will be copied here for me. Okay, so now I have those phaser that recorded from the real event. So if I click OK here to start the automatic search, then the program will analyze the current and voltage here and suggest the best fault type that matches it. Okay, in this case, it looks like a 3-phase to ground. I know there's A phase to ground. Let's see, phase A quite high. The phase B and C is normal. Voltage on phase A is quite depressed when the voltage on the other. So this is a program predicting it correctly. But sometimes if you have a more complex situation and you know better than the program, you can just change it here. So when I click OK, the program will try to seek for the best location that matches those numbers. I click OK, and it come back. It simulates a number of simulations, getting closer and closer to where the fault is. And here is the best result that it found. Okay, and it also show you some kind of phasor comparison here for you to find out. And this, the best condition that it was found matching is the fall at about 36% on the line, 36% of the line from here. And it's also try a number of fall resistance to see if you can improve the condition, and it did. So those are the matching of how those phasor, the red phasor are the simulated phasor, the blue phasor, the one that from the event file, and they match quite well. And this simply one of the best match. So you can also go here and start adding other fault here if you want to simulate it manually. And then if they are matching match better, you can add to this box here. Okay. So finally, once you are satisfied with the search, you can print a report to the TTY that show the where the input, what's the sample the number that you use, and the location that selected as one of a few locations that has the best matches. And we found from experiment and trial with the real number, real system, this for location is performing quite well. And it's quite insensitive, it's quite tolerant to a lot of different network conditions. For example, you have a low load or high load, or you have mutual coupling. It seems to be taking all those into account, searching the same with the same accuracy or better than the relay, the normal relay report. So I guess that's it. Okay, so that's the tool, and also we also carry out this diagram for you to just a normal. Is say if you have if you simulate a fall here, or maybe some of the intermediate fall, you can bring up this same format of the phasor here. So the new phasor is different from the old one. In the old one, you have a lot of buttons around it. We see it more cleanly now. And to get all the options that you can change in the phasor, you click on this button down here, or you can also simply double click on it. So the content of the phasor is exactly the same as before, but for the new, you have many new options. For example, right on this phasor, you can specify additional markers that you can put up here so that you can compare with, so if I say 11 here at the 90°, then you see this 11 and 90 show up here. And why this, did I say 11? No, this, yeah, KV line to neutral. Okay, so yeah, I guess so that's the kind of convenient thing. Of course, you still can open up to 3 phaser at your point, and you see how much cleaner it will look now compared to all the buttons that you have earlier. Okay, again, remember you can get back all these goodies to adjust the phaser property by clicking on the button down here. Okay, and there's a number of other small tools that we build into the program to make it easier for you to navigate and use the program. For example, I'll show you a couple of examples here. Let me open another file. It's kind of easier to show it. Okay. Okay, so here's an example. Okay, you are here. You want to go to remote line and at the remote end of the line. So you know that there's a view go to end bus command, which is a shortcut letter E before. But I guess that before I just show you a list of buses and you have to guess where is the real end, where is the tab end. But now, guess no more. The list box now is showing you more or less representation of that line, starting with this bus 1011. Go to tab, this tab here is 6834, and this has 2 tabs of that, but the real line going back to 6833, which is this one here. Each time you select, you see the screen refresh behind it, and this one has another tab, but going to this one, but this is not the real one. It goes further here, and this is the real end of the line. Okay, so with this graphic representation, there's no guesswork to find out where the real end is. So that's you can also use this for other purposes. The same concept is applied to so-called the oh no, not this one. Then you go to say this one. So you open another file. Okay, so this file is easier to see. Okay, so if I have a relay here that I want to form a backup for this relay, primary backup coordination pair, if I click on this plus button here, the program is now showing a graphic representation of this relay group here from Nevada to Ryusen, and also everything behind it as a graphic, so that you know exactly which relay is supposed to protect this one. So I think in this one, this one is missing, so I just can right away I can tell that this one has to be a backup for this one as well. So with this graphic display, you won't have any to do any guesswork, as well as this relay group backs up. So this one had to back up something on here and on here. So I click here. So I guess this is this relay group, and I guess there's nothing further up here. Oh, there's one here. So this one has to be the backup. This one should be backing up this one. Okay, so I guess that's the idea. And there's all the program options are now at the consolidate in the file preferences, and also I guess just another note here is that's another productivity enhancement. When you do the acquire graphic from another file, you have more flexibility to put those graphic on the screen. And there's also a number of additional report, which is, for example, if you open the relay, the network browser now, you will see that the network browser, you open the, say, distance relay phase. You'll see a additional new column that say zone 1 reach, zone 1 delay, zone 2 reach, zone 2 delay for every relay. So those are the convenient for you to report. And there's if you use tag a lot to manage your data, you have the command and the view now. You can show the things that are tagged online. And lastly, I want to mention that if you use a program to produce a relay test file, like the one that go to the Dovo test set or Omicron, or you have a number of new options here when you select. It used to show allowed only phase or sequence, but now you can, as convenient, you can do 3i0, which is exactly what the test set required, and also 3i2. Also you can specify the phase rotation and also the reference phase on those quantities. So that is small enhancement. Okay, so I guess that's the very quickly the kind of quick show of all the thing in that seems to be new in this program. And when you have the, if you haven't got the program yet, you should be able to receiving them soon, and you can play with them and then find out what's what else is new there. Okay, so let me take 5 minutes to see what's any questions here. Okay, then we go from the okay, so there's a question here is the where's the bus fault summary baseline data come from? Okay, so the question is, where does the baseline for bus faults? It is just another bus fault summary command report. You just produce that once to keep it as baseline, and then the next time you just read it back in for as the input, and it would produce a new report, which, as I showed you before, has all the baseline information recorded into it. So you can just keep using the previous bus fault summary command as a base as an input for the next one, and eventually you will get the report as you want. Okay, and okay, and I guess that's the the E end of line is still the shortcut still there. Yes, of course, and even though it didn't say it, but I guess if you go here and say E, it should still show you everything, except when you have more than one. That dialog box will show up if there's a more than one thing, more than one end. So if I highlight here, then E it show you me just the two. But if I happen to make this a tab bus, then now there's no. If I click E now, it will show up. This dialog box will show up with showing the all this. Claytor and Theodale and Ohio. Okay, so E still works, obviously. And okay, and okay, for the line fault summary report, how many intermediate fault does the report run? None. We just can. So the command just if you select this for the line fault summary command. This is the so-called level 1, this local level, and this is a remote one. So you the fault can run here and also at the line end here. There's no, it doesn't include any fault in the middle. Okay, and the goal is again to get the maximum and minimum current here. So I guess everything in the middle may not be contributing to it. I guess that's my time is up. So I guess I will save the all other questions, and I will try to get in touch with you with those, if I know the answer. And if you have further questions, go ahead and send it to support@aspeninc.com, and we'll be glad to take care of them. And by the way, we'll be in Atlanta next month for the Georgia Tech meeting, relay meeting. If you happen to be there, it will be even great to meet up and chat with you guys, whatever. On whatever you you have in the term of questions. Okay. All right. So I wish you the good rest of the day. It's 3 p.m. Pacific time now, so I guess let's stop here. And I hope to see you soon at one of the meeting, or see you online with on an email. All right. Okay. And thank you and bye.